Alright, so I'm actually going to do 12.4 this time. The one labeled 12.5 in the video series is, I start off as saying it's 12.4. It's not. It ends up being 12.5. So sorry about that. Kind of rushed through it and jumped right into 12.5 because I got excited with Pythagorean's theorem. So 12.4 is really, really easy, guys. Talks about a relationship with two tangents intersecting. And so if I have a circle and there's a tangent going along with that circle like this one, and it meets another tangent, we'll say like this one, we'll say like this tangent, like that. Well, the relationship that exists, we'll call this, let me extend these a little bit here. And I'll extend this one a little bit too, so I can make a point. Alright, so I got those two there, and we'll say that this is point A. Can't see it, that's point A. This is point B. This is point C. Okay, well, then we know, and it looks fairly intuitive, but the relationship that exists here is that A, C, and BC are congruent. AC is congruent to, it doesn't pop real well, does it? It's congruent to BC. BC. That's line segment, and the and so the line measures are the same. So whatever you have set up for there, that's your relationship. Write it in accordingly, and then solve for whatever you need to solve for. But now, say for instance, I have a circle over here, right? Let's say it's a little circle like this. That's like the edge of it. That's a bad circle, but I have points. You see D and E right here. So now I have line segment. CD, and I could say line segment CE. Well, those are congruent as well, right? Not a big surprise because this is just like kind of that flipped over. Those are also congruent. And if you know anything about the line segment addition postulates, you will recognize that if I take the two line segments that are congruent, the pieces parts are congruent, and I add them together, then I know that the blue and the purple, so BD and AE line segments, you guessed it, are congruent. They're congruent, right? So they may give you different pieces parts of each one of these, right? And like we said, every time you label what you like, write down the equation, write down the givens, transcribe the givens, write down what you know in general terms. That means with the givens, or not with the givens, with the points written, and then figure out what you need to use. All right, so where's an example? Here is an example. Let's use this one. Okay, so we have PZ. This line segment is 10x, 10y minus 3. And I got ZL, which is another purple, the extended part of the purple line. Oh no, it's 4x plus 10. 4x plus 10. Oh man, those are different variables. Man, oh man. Okay, and then we have GZ. It's a different line. GZ is 7y plus 21. And I have ZK is 6x. 6x minus 16. Well, let's write down our general equations that we know. We know these two are congruent, and we know these two are congruent. Alright, so that's what we know. So we can write in general terms, we know that PZ plus ZL equals PL. We know that GZ plus ZK equals GZ. GZ, but no reason not to put that there. Those are two general terms. And we know that PZ equals GZ. Yeah, I'll do that. Equals GZ. And we know that ZK equals ZL. ZL. All right. So now we gotta write an equation that solves for x. Well, I gotta use equation that solves for x. Let's see, look at what my variables are. Okay, my x variables are over here. I'm talking about this blue line, which is ZK, and ZL. They're equal to each other. Okay, I need to use this equation. So ZK equals ZL. So let me just substitute some numbers. 6x minus 11 equals 4x plus 10. All right, variables left. Well, I'm going to move my variables over here because 6 is the biggest one and 2 and 4 is the smallest one. So this will make 2x equals, let's see, is that I didn't copy that down right. That is 6x minus 16. That's always important to double check when it comes out funny, because that would have came out to an uneven number, which I didn't think it would have been clean math. All right, so I double checked, found a transcription error. So, and 2x equals, and then 16 plus 10 is 26. So x equals 13. So I did 4 and 5. Okay, now I'm going to solve the equation for y. So I did this one. Now I'm going to be using PZ and GZ. So I know that PZ equals GZ. So PZ is 10y minus 3, and that equals 7y plus 21. Same song and dance here. I'm going to move the 7 over that side, so I'm going to end up with 3y. 3y equals 24. Equals 24, so y equals 8. All right. So now GX. GX is what I'm trying to solve. I already have that value. Put it up here, but I wrote it wrong. GX. So my GX is GZ. So from here, I think you guys can figure out the rest, right? I plop in my x and y values into their respective equations, right? So 8 would go here. Sorry, this would be 8 would go here. That turns into 8. This turns into 8. This turns into 13. This turns into 13. And then do these maths and then add these together to find your respective equations or your respective values. Okay, so that's how that whole stuff works out. Hope that helped out.